Hi all the students. Today we are going to study another technique of switching or another switching technique which is known as message switching. Now in our previous video we have discussed circuit switching. So let's see what message switching is. So basically in message switching it is a technique which was developed as an alternative to circuit switching. Now, as we all know that in circuit switching, dedicated paths are established between the sender and the receiver. But there is no such scene in a message switching, right? So it is an alternative to circuit switching, and it was basically developed before packet switching. So as you know, we have three kinds of switching techniques: the circuit switching, message switching, and the packet switching. So first came the circuit switching, then message switching was developed as an alternative to circuit switching, and it was developed before packet switching came into the scene, right? Okay, so basically what happens in message switching is that in message switching, the end users are basically communicating by sending and receiving messages which include the entire data to be shared, right? So first of all, there is no dedicated path over here. The communication channel or the communication link is shared among several senders and receivers, right? So the communication channels are basically shared among various sending nodes and receiving nodes. First of all, there is no dedicated channel or dedicated path between the sender and the receiver. Then second thing is that the message is sent in its entirety. That means you send the entire message all at once. So basically the message is not fragmented into smaller data units as mostly it is done. So in most of the cases you have seen or you have heard that the message is first broken into smaller units and then those units are transmitted individually. But here the whole message is transmitted in its entirety. That means the complete message is sent at once, right? Now one thing here is that the sender and receiver are not directly connected. Now since there is no dedicated path, that means there must be several intermediate nodes in between the sender and the receiver, because all the nodes are sharing the communication channel and hence there is no dedicated path between the sender and the receiver. So it is quite obvious that there is not a direct communication or a direct connection between the sender and the receiver. Rather, there are a number of intermediate nodes in between the sender and the receiver who are doing the task of transferring this data which they receive as and when, and then they ensure that the message reaches its destination. So basically there is a sender, there is a receiver, and in between there are multiple intermediate nodes. Now for the message to be transmitted from the sender to the receiver, it has to go via those intermediate nodes, and those intermediate nodes simply receive and then forward the packet on the outgoing line till it is received by the receiver. So message switched data networks are called hop by hop systems. So basically message switching, the networks that use message switching are called hop by hop systems. Why hop by hop systems? So basically in terms of networking, one hop occurs when a packet is passed from one network device to another, right? It is counted as one hop. So as I said that between the sender and the receiver there are multiple intermediate nodes. That means by the time they actually reach the intended receiver, they pass through several intermediate nodes. So this process of passing the packets from one device to another till it reaches the intended receiver is counted as a hop. So that is why the message switch networks are called hop by hop systems. So the number of hops is basically equal to the number of devices through which the data has been passed till it reaches the intended receiver. Okay. Now, what are the characteristics of message switching? What are the characteristics of message switching or message switch networks? The first character is your store and forward. Okay, what is this? So basically the intermediate nodes have the responsibility of transmitting the data packets, as I said. So from the sender, one node receives the packet, then it passes it on to the another node and so on till it reaches the intended receiver. So basically the intermediate nodes are responsible for transferring the entire message till it reaches the intended receiver, right? So this way they keep on transferring the data message or the data packet from one node to another, hop by hop. So each node must have a storage capacity. So when an intermediate node receives the message, it will store it for some amount of time. It will see if there is an outgoing line, and if that line is free, only then that packet or that message will be forwarded. So for that time, until or unless the intermediate node forwards the data packet, until that time it will store it. So what does that mean? That each intermediate node, or each node rather, must have storage capacity, right? It should have capacity to store the packet that has received until it forwards it from to the outgoing line, right? So basically a message will only be delivered if the next hop and the link connecting it are both available. That means the channel is available, right? Only then it will be forwarded from the node which has received it to the other immediate node. Otherwise it will be stored indefinitely. Indefinitely means for as long as the channel does not get free, because if the channel is not free, there is no point forwarding or transmitting that particular message, right? So until the channel is free, the intermediate node will store that message. Indefinitely means for as long as the channel does not get free. So that clearly implies that the nodes must have storage capacity to store the message for that particular duration till it is not forwarded through an outgoing line, right? So a store and forward switch basically, or a store and forward router, switches are your routers which are basically doing the task of routing the messages, finding out the best possible route for the messages, receiving them, storing them, and then finding out the best possible route for forwarding them. So basically a store and forward switch or router, what does it do? It forwards a message only if sufficient resources are available. Now these sufficient resources are what? They are basically, most importantly, the communication links or channels. If they are available, only then the message will be forwarded, and the next hop must also be accepting the data. That means the next node which has to receive the data must be accepting that data. Only then the switch will forward the data. So two most important things. First of all, the channel must be free through which the data has to be transmitted or the message has to be transmitted. Second, the intermediate node which has to receive that particular message must accept it. Only then it will be forwarded, right? Now this is called the store and forward property. That means you store it and then you forward it. Then again the next node will store it and forward it depending upon the availability of the resources. Okay, so the second characteristic. So first characteristic that we saw was store and forward. Second is message delivery. What does this mean? This means that the entire information is wrapped in a single message. That means you send the complete information all at once rather than breaking into smaller units and then transmitting. So all the information, the entire information is wrapped in a single message. Or in other words, the message is sent in its entirety and then it is transferred from the source to the destination node, of course, via intermediate nodes, right? So each message must have a header, right? That contains the message's routing information, that how that particular message must be routed, what are the source, what are the destination. Of course, to route the messages properly, you must have information about the sender and the receiver. Only then you will be able to choose an appropriate part for the message. So the routing information, and which also includes the source and the destination information about that particular message, right? So up till now, whatever we have studied about message switching, from this we can easily conclude that there are three important elements of message switching. And what are these three important elements? First of all, these are the transmission links or the channels through which the message will be transmitted. Then the store and forward switch nodes, which are doing a very important task of storing the message, receiving the message first of all, then storing it until they find a free outgoing line to forward that node, as well as until they find the next intermediate node which is accepting that node, right? So it will store and then it will forward. Such store and forward switch nodes. So the nodes, basically the intermediate nodes which are accepting the data and then storing them and then forwarding them after finding an outgoing free outgoing line, are known as the store and forward switch nodes. And the end stations. End stations are the transmitter and the receiver, right? So these are the three important elements of any message switching network. Okay. So basically, after studying all this, we must be able to conclude that what are the advantages and disadvantages of circuit switching. So what are the advantages first of all? Now, message switching ensures that traffic is efficiently regulated and controlled. Why? Because of the store and forward capability. Because the message is not forwarded until you find a free outgoing line. Right? So that means there is no possibility of congestion over here. So obviously the traffic is well regulated and controlled. Okay, now the second advantage is that message delivery is as one single unit rather than in pieces, right? So if the message is received successfully, then it is received in its entirety. There is no probability of losing one unit of message and receiving the other unit of message. So the message is, if it is received successfully, it is received in its entirety. That is another good thing about message switching. So these are the advantages. Now if we look at the disadvantages, now since you know that messages are stored indefinitely, that means we do not know when, if we are not sure of when the outgoing line will be free, then we cannot forward the messages. So that means if the outgoing line is not free for a longer amount of time, then that means the messages will be stored indefinitely at the intermediate node, right? So switches, for that reason, switches require larger storage capacity, because they may have several such intermediate messages. They may have several such messages which they receive at a point of time. There is not one such message that they receive. The intermediate nodes can receive several such messages, because obviously this is not a dedicated path. This is a shared path. So several transmitters may transmit their message at the same time. So if the intermediate node has received one such message, there is a probability of that intermediate node receiving like 2 or 3 more such messages. That means the intermediate node must have sufficient storage capacity, because unless the outgoing line is not free, the intermediate node will not be able to forward those messages, right? So hence it implies a requirement of a larger storage capacity. So this is one disadvantage. Another disadvantage is that message switching is quite slow. Now why it is slow? Because at each node there is a wait. The message is received at the intermediate node, then there is a waiting period until the intermediate node finds an outgoing line which is free. It will not forward it, right? So the entire message waits for that duration of time. Then it must be stored and transmitted after processing to the next node also. Now once the one intermediate node finds a free outgoing line and another intermediate node which is accepting of that message, then that message will be stored at that next intermediate node also. Then that intermediate node will also do the same thing, look for a free outgoing line, and another intermediate node which is again accepting of that message. So this process keeps on going until the message is finally delivered at the intended recipient, right? So that means, of course, that causes a delay. That causes an overall delay in the transmission of data, right? So this is another disadvantage. So hence I can say that message switching cannot be used for real-time data, because it takes time, and in real-time data, time is the biggest time is the biggest thing that you cannot compromise on. time is one such thing which you cannot compromise on. In real time of data, you can compromise on the quality to a slight extent, to some extent, but you cannot compromise on the timing. Real time is, that means that is happening now, right? So for example, if I am conducting a video conference, that is real time data which is being transmitted. So what I am speaking right now in a video conference cannot be delivered 30 minutes later. It has to be delivered the same moment when I'm speaking it. That is real time data. So with message switching, you know that there is a waiting period. So messages cannot be, the delivery time is comparatively slow in message switching. So hence, message switching cannot be used for real time or interactive applications, as I said, like for a video conference. So this is all about message switching.